Assalamualaikum, my name is Karun Najwa binti Kamalazi and my matrix number is TF220132. So let's go through the introduction first. So we aim to design the Truss tower 100 mm tall and 300 mm by 300 mm base using static and glue or thread. So the project is divided into design, analysis and presentation. So the tower must be withstand 10 kg load. So next is the objectives. So design a truss tower meeting specific dimension, validate the design and manual calculation and software simulation. Next is analyze terminal forces and deflection under the 10 kg loads. So next, moving on to the methodology. So we follow this step: design selection, calculation, material collection, building, repairing, testing and reporting. So let's go through one by one. So design selection, which is brainstorm and refine multiple design. Calculation, perform manual calculation and validate the Tekla software. The material collection, gather the static, glue, tree and others material. Building is assemble the tower with precision. Repair reinforcement joint and adjust the structure for stabilize. Testing, conduct the load test with 10 kg. Reporting, compile the calculation, design iteration and construction processes into a report and create a video presentation. So that's all for me. So I will pass to the next presenter.
Hi and Assalamualaikum. My name is Siti Ashraf binti Abraza. My matrix number is TF220085. Now I would like to present about manual calculation. Okay, first of all, this is our two dimension of tower. Okay, now I would like to explain how to calculate by manually. Okay, first I just find the reaction and the internal force for the beam at the top. Okay, first we must find the structure is determinate or indeterminate. For our case, our structure is statically indeterminate with 2 degrees, and then I find the reaction at RAY and RDY. Okay, for the load is 0.05 kilonewton for the both of joint. Okay, for the reaction must be same at the point at the upside must be same for the reaction. Okay, for the reaction of RAY and RDY is 0.05 kilonewton because of the load at the bottom is 0.05. Okay, next find the internal force. For internal force, I found that member AB is negative 0.05. Why negative? Negative because of the force is compression. If compression, so the load is negative. Okay, for the member AD is 0 because of there's no load from axis X. For member DC, 0.05 compression. For member DC, 0. Member BD and member AC also 0 because of the member from the axis is 0 and no load that for the hypotenuse. Then to find the deflection, we must virtual load. One load I put the virtual load at the axis X at point D. So the internal force for first find the reaction also 0 because of there's no load at from axis Y. From axis X, the load is 1 from at point D. So the member AD is 1 tension because of the load is outside. And for the other members is 0 because there's no load after that. And then put all the data, all the force that we found in the column. The column is member. First member, list all the member of the column. List all the member of the structure. There's 6 member and list all the 6 member AB, AC, AD, BC, BD and CD. Then the next column is length. Length is based on our distance that we put. The length for AB is 0.2 meter, AC is 0.36 meter, AD 0.3, BC 0.3, BD 0.36 and the last one is CD is 0.2. For the F prime is the load, is the force, internal force from the real load, and for mu is the load, internal force from the virtual load. Next, for the next column is F prime mu L Then find the total for F prime mu L. Then find the next column is mu power of 2 times L and find the total. The total for mu times 2, mu power of 2 times L is 0.3 and the total for F is negative 0.10. For the deflection at RD is 0, multiply 0.3 equal to 0, and for the deflection for RD is 0 so that I can conclude at here our tower suitable for 10 kilogram. That's all from me. Thank you.
Assalamualaikum, my name is Nuzafira Zaini. So today I will be presenting the structure analysis of a tower model using Tekla software for calculation. So to start with, the type of load applied in our model is a point load. Specifically, there are 4 point loads applied at the top of the tower, each positioned at the joints. The value of each point load is 0.2 kN. So the type of support used in the model is fixed, providing stability and resistance against movements and rotation at the base of the structure. So the material used in our model are steel, which is known for its high strength and durability, making it ideal for such structural applications. Additionally, it is important to note that the scale used for the analysis is times 8. This means that all dimensions including beams, columns and point loads are multiplied by a factor of 8, which is to enhance the visibility and the accuracy of the analysis. So continuing with the analysis, let's delve into the internal forces and deflection observed in the tower model. So as you can see on my left side, we have the internal forces diagram that illustrates the distribution of forces within the structure under the applied loads. So understanding these forces is crucial for ensuring that the structure can withstand the applied loads without failing. On my right side, we see the deflection diagram. This shows the displacement of the structure under the given loads. As indicated, the first order linear analysis with the given dead loads result in a total member deflection of 0.0 mm. This suggests that our structure is well designed and can effectively manage the applied loads without significant deformation. So this concludes the overview of our structural analysis using software calculation. The fixed support, steel material and applied loads have all contributed to a stable and robust structural model. That's all from me. Thank you.
I am Kepuja Pedingkong and my matrix number is CF220065, and this is data analysis. When we calculating manually, each point load is 0.05 kN is used, but when using software it is 0.025 kN. This difference occurs because in manual calculations, load from the front and back of the tower are combined, and in software the loads are divided into 4 point loads at the top joint with the total load remaining 10 kN. Point loads are used because in the actual design, the beams are not level with the peak of the column and load transfer directly to the tower column. In testing, the tower held 11.2 kg for 30 seconds and fell at 15.2 kg. It was designed to withstand a maximum of 10 kg, so the tower structure fell. Both manual and software calculations assume a fixed support, making the structure statically indeterminate with 2 degrees of freedom. When designing for a 10 kg load, no deflection was assumed. Therefore, both calculations, manual and software calculation, shows there are no deflection, indicating that there are no major error or differences in the design analysis.
Hi, Assalamualaikum. My name is Nufrazli binti Zahid. My matric number is DF220161. So today I'm gonna talk about discussion. So the base size of tower is 300 by 300. So from base to the first member is 220 in millimeter, and the middle member is 0.7, and height of tower is 800. So we follow all the requirements that professor has given to us. So after we test the tower, surprisingly, the testing was able to withstand a load of over 10 kg for more than 30 seconds. But we have to put more load until the tower bent. So So after we put more load, finally it crashed at 14 kg. But after we plus the plate tray, okay, actually it crashed at 15.2 kgs because the plate tray weight is 1.2 kgs. So why our tower crashed at 14 kg? Because 4 column which cannot sustain more load in the future. And other than that, it has different height, which means it's unlevel column. That's why it twists like a cheese, okay, make my tower crash. And other than that, we use soft clay to support the pin. So I think my group the only one that tower that only has base and the soft clay. But actually, why we use soft clay? Because we thought the soft clay will be hardened in 3 days. So it's unexpected. The soft clay is not hardened at all. That's the reason why our tower crashed at 14 kg. In the conclusion, we really love our tower because it can sustain 10 kg more than 30 seconds and crash at 14 kg. So this tower is aesthetically indeterminate with 6 degrees and we use Step Light and Step Pro. Why we choose 205? Because we want to know which one is the best for our tower. So our suggestion for this tower is we want to suggest use a bit thicker material for the pins, okay, such as a hot glue gun at the bottom first and then use the soft clay or use the hard clay. Other than that, we should measure to get same height. As you can see, X only have 4 columns. To make it more sustain more load, we have to put more column at the bottom. So other than that, our limitation for this project is limited of the material. Okay, material access is very limited and lack of lateral support. So what we want to improve is we want to upgrade material that can be used. Maybe we can use metal rods or carbon fiber sticks, okay, because this material is more sustainability. So for the lateral bracing, we want to add lateral bracing element such as a diagonal force braces or crossing braces at various levels. That's all from our group. Thank you and bye. Thank you, Professor.